All right. And again, feel free to go through this list. There's the select gas function in here as well that will allow you to switch gases. There is a data on, data off command. I can just drag that up in here. So basically, this command will allow you to sort of eliminate certain chunks of your experiment from being recorded, essentially. So wherever it hits a data off command, which is just by unchecking that box, it will switch off the recording function. So anything below that will not be recorded until it sees another data on command. Then it would start recording again. So if you have something, for example, you have an equilibrate step that is really an uncontrolled heating or cooling, most times it really doesn't mean anything to most people. So you don't want to record that. That's okay. You can surround it with the data off, data on command, and that way it'll just not record that step. Okay. If equilibrate is the first, is step number 1 in your procedure, by default it does not record anything. Okay. So if equilibrate is step number 1, it does not record anything until it gets to step number 2. But if you have an equilibrate in any other place except step number 1, it will record it. So if you don't want it to be recorded, then you would have to use the data off, data on command to sort of surround it with that, and then you're good to go. All right. So these are, again, feel free to sort of look through all of the commands that you can use and what they are useful for. Trios has a very substantial help menu, so you can literally look up each one of those things, and it will give you a nice description of what they are and how you can use them. Okay. So once you are happy with whatever your experimental procedure is up here, you simply hit apply, and it would save everything as is. Okay. So this will be my new supposed experimental procedure that when I then put this into the running queue, these are the instructions that the instrument will follow directly. Okay. Now, scrolling down a little bit further, we have this sort of advanced section down here. This is important for the TGA for 2 reasons. The first is this begin of test, which is basically what happens as soon as it picks up the sample and puts it into the furnace. By default, the start experiment after weight stabilization, that is checked by default, right? So it's activated by default. Basically what happens is that if you have a stable material that's not going to change its weight, in standard atmospheric conditions, what it's going to do, it's going to bring the sample into the furnace. It's going to close the furnace, and it'll wait a couple seconds, maybe about 30 seconds or so, for the weight itself to stabilize. Okay? Of course, if you don't have a stable weight, you don't have an accurate weight calculation. So it waits a couple seconds for the weight to stabilize, and then it will start the test. Okay? Now, let's say I have something that has a bunch of solvent in it, and I want to figure out my solvent concentration. Well, having it wait that 30 seconds, the solvent's continually evaporating, right? So my weight's going to be changing that entire time. So the best thing to do would actually be to uncheck this button. So in that case, what will happen is that it will carry it into the furnace, and as soon as the furnace closes, it will start recording, and it will start the experiment. Okay, so it does not allow any delay time. Once this is unchecked, it does not allow any delay time between when the furnace is closed and when the experiment starts. It starts immediately. But this is only for when you have unstable samples or volatile samples that are volatile in standard atmosphere. If you have something in a water suspension or ethanol suspension or maybe a hydrogel, something that would basically continually lose mass over time and which would actually change some of the values that you may want to use later on, you want to uncheck this. If you just have a standard stable powder or any type of material like that, polymer, inorganic, that's just stable, then you want to make sure this is checked to get the right mass before the experiment starts.
Usually, how long for the stabilization?
I would say maybe about 30 seconds, no more than that. 30 seconds, yeah. So not very long. I'm not even sure if it goes fully 30 seconds, but somewhere around 30 seconds for it to stabilize. And once it does, it'll start the experiment on its own. You don't have to do anything, okay? So that's one of the reasons for this advanced tab down here. The second reason is the end of test. Now, the end of test has this user-defined unload temperature. And right now it says 50 degrees Celsius. Now, the unload temperature is simply the temperature between two experiments where it would unload one sample and put in the new one. Okay? So for example, let's say I have 3 tests that I'm running. In between test 1 and test 2, right, it will cool down to 50 degrees Celsius. When it hits 50 degrees Celsius, it would take out sample number 1 and put sample number 2 in. Now, the problem with that is that it's putting it in at 50 degrees Celsius. So if you're starting your experiment at 100 degrees Celsius, then this number doesn't really matter. But if you're starting your experiment or you want to start your experiment at room temperature, then 50 degrees is definitely not room temperature. Okay? So what you would want to do is you want to change this number, and the lowest number you can choose is 30 degrees Celsius. Still not room temperature, but by the time your sample gets in there, it's going to be in the range of 25 to 27, which is a lot closer to room temperature than 50. All right? So if you are concerned with that temperature difference, you want to make sure that your user-defined unload temperature says 30 degrees. All right? And that it should say that for each experiment that you're running. Okay? Now, if you're just running one experiment, then it doesn't really matter. Right? Once the experiment's done, it's done. But if you're running multiple experiments, one behind the other, and you want to start each one of them at somewhere close to room temperature, you need to make sure that this number is typed in there, because the default is 50. So you always need to scroll down and check and change this number to 30 degrees. Okay? So those are the two.
Enable air cool.
The enable air cool, this is, it also happens at the end of the experiment where the furnace opens. So the furnace opens anyway at the end of the experiment. Well, it only opens when you have another experiment to run. Okay? So this all only happens if you have another experiment coming right behind it. If you only have one experiment, this part doesn't matter at all, really. So if you have another experiment coming, what will happen by default is that it will drop the furnace down and it will just cool. And it just cools down, right, to somewhere close to whatever this number is, and then it will switch out the old sample with the new sample. Enable air cool just allows this to happen a little bit faster. The air cool is essentially going to blast, in this case it's not really air, it's going to be nitrogen. It's going to blast nitrogen through the furnace to help cool the furnace down a little bit faster. If you want to save a couple minutes, then sure, you can switch the air cool on. But honestly, with the IR bulbs, it cools down relatively quickly on its own, such that I never really have to use this. So I generally don't use it, but you can if you so choose to maybe save a couple extra minutes at the end of every experiment. Not too big of a deal for me, but if you would like to, you can always feel free to use that. All right. So that's the reason why this advanced tab is important for the TGA. I didn't really talk about it much with the Discovery DSC because there's really nothing that important down there. But for these two, this could be important depending on the type of experiment and the type of sample that you're actually running. These could be very important to you. All right, so I need make sure to mention them in the training. So, oops, what happened here? All right, so let's say that I'm finished now with my experimental setup. And remember, I did everything in the design view, right? So whatever is happening up here, I didn't mess with, okay? So now I have to take this and move it into the running queue. And all I do is click and drag and release. And you would see it basically copies whatever is down here onto my running queue, and everything gets moved with it, okay? Right? Everything gets moved with it.
If I want to have two samples.
Yeah, if you want to have two samples, you can create both of them down here and then drag both of them up.
Can I just use the same one and add it?
Yes. So what you can do here, so for example, if I go back to design view, and you can do this with the running queue as well. So any function that I'm doing here works in both the running queue and the design view,
okay,
right? Because they're identical to each other. It's just that the running queue talks to the instrument and the design view does not,
okay.
All right? So what you can do if you want to add another experiment, so example, I have experiments in pan 1, pan 2, and pan 3, okay? I click on this button, and I say clone the appended run, and I just click that button, and it's going to automatically change the pan number. So I went from pan 1 to pan 2 to pan 3, right? And basically everything that was in this first experiment is now in the other experiments. So it copied everything. So if you're going to run the same experiment with 3, 5 different samples, you only need to prepare one experiment and just copy it down, right? And then now I can take all of these and copy them up here. Well, actually one at a time, it looks like. Hold on, delete that. So I can click here, click and drag, set the second one up there, click and drag, set the third one up there. Okay? So they all get up there, and you only really, I only really need to set up one experiment and copy everything else. Right?
Question comes into routine that you told me when you set up the experiment, it first measure the empty pan.
Yes, so the tearing of the pans, that will come, I'll show you how to do that now actually. So this is the software part of it. So at this point, you're not pressing start yet, okay? You only press start after you tear your pans and after your sample is on the pans. This is just how you set things up on the computer itself. But for right now, like for example, if I wanted to run these 3, I still have some stuff to do before I press start, okay? But so the computer part, so the part of setting up the experiment and telling it what I want to do, that's completed. But now I have to prep the sample and load it onto the instrument, okay? So you can do that before or after you get onto the computer, just a matter of preference. But, you know, it's really just a matter of preference. It really doesn't matter which direction you go into. Probably only if you're doing more sensitive samples that you don't want them hanging out in air for too long. You may want to set this up first and then put the samples on so that it's not staying out in the air atmosphere for a long time. But if your samples are stable, either way works. Whichever one you want to do first, that's up to you. As long as you do both of them before you hit start. Okay? So this is how you prepare everything on the computer. Now I would show you how to actually prep the sample to get ready for actually running this and hitting the start button. Okay? So you can go back over.